I'll show you two ways to do this question. First of all, the quickest way, which is actually to work backwards. And I'm going to look at how many waffles Red Riding Hood had just before each kind of interaction. It's just I'm going to work backwards. So she starts with 0, and then just before the third granny, she would have had X waffles left. That's the final amount she's given. Now, because she delivers the same number of waffles to each granny, that's the number she's going to give each time. So I'll just make a note of that. And then we've got the wolf, the third time. So maybe I call it wolf 3. It's not the third wolf because it is the same wolf, but I'm just going to write 3 to illustrate that. Right, the wolf ate half of the waffles, so I need to double X. Must have had 2X just before meeting that wolf. Now, just before meeting the second granny, because she gives each granny X, she would have had 3X. And then meeting the wolf the second time, because it's eaten half to get down to 3X, we double it to 6X. She must have had 6X waffles just before meeting the wolf for the second time. First granny, she's given X waffles too, so 7X. You can see we're just following this pattern now. And then the wolf, the first time, would have eaten half, so we need to double it. She had 14X waffles at the start. It's necessarily a multiple of 14, and hence it is necessarily a multiple of 7. Right, alternative approach now. I'm going to actually, so this is going backwards. Now I'm going to go forwards. So we're going to start with, I'll call it W now, just so I'm not saying it's the same thing as X. So we start with W, and then it's going to meet the first, start with W, and then it's going to be wolf number 1, and we're going to be left with W over 2. And then we're meeting granny 1, and we're going to have W over 2 minus some amount. Yeah, arguably this approach is not as good because I've got 2 unknowns, but if I can kind of link them together, then I'll be sorted. And then wolf number 2 gets half of these. So it's going to be W over 2 minus D over 2, which I could multiply top and bottom by 2 to give W minus 2D over 4. It's a little bit nicer. And then with granny 2, we're going to be left with W minus 2D over 4 minus D, which I could simplify actually. I could write this as 4D over 4, and hence it's going to be W minus 6D over 4. Okay, on to the third interaction with the wolf. We're going to lose half. So actually this is in quite a nice form now, because if I just divide this by 2, it's going to be W minus 6D over 8. Because when you divide by 2 over 1, it is the same as timesing by 1 over 2. So I can just basically times the bottom by 2. And then finally, third granny, we've got W minus 6D over 8 minus D, or I could write down minus 8D over 8 to put it over the common denominator, and hence W minus 14D over 8. Now note, at the end she has no waffles left, so this is necessarily equal to 0. And therefore, it doesn't matter that I'm dividing by 8, it must be that W minus 14D is equal to 0, and hence W, the total number of waffles she'd had at the start, is equal to 14D. The D is the amount she gives to each granny. So again, multiple of 14, multiple of 7. More complicated approach. This is actually how I did it, and that just felt quite natural to work going forwards. But I have seen these sort of questions now a few times where it's actually just more advantageous to work backwards. So it's something that I'm going to take on board, and that's why I went through this one first. So yeah, you don't always have to just work chronologically. You can work you can work backwards as well. But yeah, whichever you like, both are good to see. This one's more complicated. This one's actually in this case it's not really hard to get your head around. Sometimes I think it is. I've seen a junior maths challenge question about spoons where actually it was easier to work backwards using the maths, but less easy to understand what was going on. So I guess at the end of the day, let's try and master both.